Hello everyone. So today we're going to see the design principles of blockchain. So in total, there are 7 design principles that go by decentralization, immutability, transparency, security, scalability, privacy, and flexibility. As we go ahead, we're going to see each one of them taken one by one. So let's just start with decentralization. Picture this, okay? Just imagine. Normally, if you want to send money online, you go through a bank. The bank checks, approves, keeps the record. But what if I told you we don't actually need that middleman anymore? One of the main benefits of blockchain technology is this. What? Its decentralized nature. This means that instead of relying on a single authority, on a bank, on government, transactions are verified by the network, by the nodes that are participating itself, right? So we don't need a third party. So if we don't need a third party, we don't have a central authority governing anything. So let's just see who benefits from this. Let's talk about the businesses or maybe the startups actually that might not have enough resources to build expensive infrastructure for transaction processing. So what they can do with blockchain is they can just plug into a just plug themselves into a decentralized network that is going to handle the trust, that is going to handle the verification automatically. And you know where it gets interesting? By separating the network from the miners and the networks, when you separate them, blockchain creates a more democratized system. Now, no single entity can grab control. And this not only makes the system more resilient, obviously, to attacks, but also ensures wealth and decision making are spread out more fairly. More people are participating in how the decision making is done, what decisions are to be taken. And it's not always about money, in a way, users get more privacy, more control over their own data. Because instead of a central authority defining rules for everybody who is engaged in the network can do so. So I believe decentralization is what gives blockchain its edge over the traditional systems, creating freedom, transparency, security, while building a system that is more fairer or that is more stronger and more obviously efficient for everybody. Now let's talk about immutability. Just think you're writing in your diary. Now, if it's on paper, you can always go back, erase something you didn't want to write, but you wrote it. And it's very go and just erase, go and just make changes, go and just tamper with the data. But imagine if every word you wrote was instantly carved into stone, that was permanent, unchangeable, untouchable. And that's exactly how blockchain works. So the second principle of blockchain goes by immutability. This means that once a transaction is recorded, it is permanent. Nothing can be done now. The action cannot be undone, it cannot be changed, edited, or tampered with. And why does this matter? Because immutability ensures that information stays accurate, information stays secure. It removes all the possibilities of any frauds, any manipulations. If money is transferred, it is transferred. You cannot change that. Okay, if I transfer 10 rupees to you, you cannot come tomorrow to me and say, hey, you gave me just rupees 8. Because the transaction has been validated, and because it has been validated, it is already in the blockchain. And same while I cannot come to you and just tell you that, hey, I gave you 12 rupees yesterday. That is not going to happen. And also, there's another benefit that there's no need for third party verification, there's no need of reconciliation. Transactions are final. Once written in the blockchain, it is considered to be final. And they are trusted to be what they are now because they're in the blockchain, they cannot be amended, they cannot be tampered with, they cannot be edited. And this is going to reduce cost in a way and also going to speed up the processes because now approval checks have not to be done after later. So, right, immutability is what gives blockchain its trustworthiness, its security. By making every transaction permanent, it builds transparency also in a way. Let's go to next. Now, imagine for transparency, I would like you to imagine you're moving into a restaurant. You just open the menu card and then you see it's just food written. You don't know what's inside the food. You don't know what are the ingredients, how are they going to cook it, what else and what not. And that is why transparency matters because you're not going to order it from there because you don't know what you're getting. If you're veg, you don't know if you'll be served some non-veg course meal. So that is why you just step back from there, right? So blockchain makes transactions transparent by letting the users see all the information associated with them. Nothing is hidden, nothing is kept behind the closed doors. So take a simple example. You're a business owner selling products online. Your customers exactly want to know what they're buying, how was it created, what are the ingredients, what was the expiry date, what was the manufacturing date, the sourcing, the process. And with blockchain, you can upload all this on the chain, and then I know there is not going to be any middleman, there is not going to be any tampering with the data that has been uploaded. For businesses, it builds trust, it builds credibility. Customers can see exactly what's happening. So they feel more confident about what they're purchasing and from whom they are purchasing. And always when trust increases, collaboration increases. And when collaboration increases, the parties benefit. Customers, they feel more connected, more loyal, and more willing to interact with the brand itself. Let's go to the next one, security. Whenever it comes to money or whenever it comes to sensitive data, the first thing people are going to talk about is security. How secure is the money? How secure is the data with you? If it's not safe in these cases, it's not at all useful. So that is why blockchain's strongest armor is the way it secures every transaction. So blockchain, we know, uses a public ledger where every transaction is recorded and everybody has a copy of that ledger, and that ledger stays updated throughout. So this doesn't mean your personal details are exposed, but it does mean the transactions are traceable and verifiable by anyone. And this visibility makes fraud much harder to pull off. At its core, we know blockchain is just a distributed database. Every node in the network has a copy of the same ledger. So instead of one vulnerable central server, you've got thousands of independent records all agreeing on what's true. When you make a transaction, you're not directly sending money. Instead, you create a new block that gets proposed to the network. If 51% of the people validate that block to be true, it gets appended to the blockchain. It's after they have inspected your block, after they've checked that it is meeting the required criteria, and then only they'll approve it. So once added, it's then visible to the whole network, making the system tamper proof. And then comes the key. If anyone tries to hack, if anyone tries to alter, if anyone tries to forge a transaction, they'd have to trick off the majority of the entire network at once, which is practically impossible because 51% of the people, if you want to trick off, it is next to impossible task. So with this, we know security in blockchain isn't just a feature, it's the foundation. And with cryptography, consensus, transparency working together, blockchain ensures that your transactions are safe, your transactions are traceable, and nearly impossible to corrupt. Then let's come to the next one. Let's talk about scalability. So, I have to get coffee in my I try to get coffee actually in all my playlist videos. So let's just think about any favorite coffee shop of yours, right? If it serves 10 customers a day, every day, it runs smoothly. Everything is running perfectly. Everybody's orders are getting processed in time. Everybody's happy with the service. All are happy. Both parties are happy. The customer party and the managing party. Everybody's happy. But what if in an instant it just goes viral and 1,000 people show up all at once? If the system can't handle the growth, it collapses. And that's why scalability matters in blockchain is no different. Scalability is the ability of a blockchain to handle an increasing number of transactions without losing speed, without losing efficiency, without losing the security model. And three main factors determine this: execution, storage, and consensus. Let's talk about execution. First, execution is about speed. How quickly transactions get processed. And this depends on how many nodes are there in the network, what is the bandwidth of each node, what are the processing powers. And then let's come to storage. Now, storage is all about capacity. The amount of data a blockchain can hold, block size, how often new blocks are generated directly, and then how much can we fit on a chain. That all comes under storage. Then let's come to consensus. Consensus, we know, is all about agreement, making sure all nodes validate the same transactions, whether they do it through voting, whether they do it through proof of work, proof of stake, or other algorithms. Reaching consensus is very essential if you want to make the system reliable, right? And where the magic begins? It's like, unlike traditional centralized systems that hit the bottlenecks quickly, blockchain allows multiple nodes to work together, verifying, storing the data at the same time. And this collaborative model gives it the power to scale and handle more activity. You understand? Because scalability is going to ensure that that blockchain isn't just good for small experiments. It is actually good when I want to implement it on an enterprise grade. And it is actually built to support mass adoption. The stronger its execution, storage, and consensus mechanisms, the more it can grow into a truly global system. Let's come next to privacy. Now, when you come here, you realize there's a paradox. You say, I mentioned blockchain is transparent, and I'm mentioning, oh my God, privacy is a very important part of blockchain. And you'll be like, what are you even speaking? Are you even hearing what you're speaking? So, this is a paradox. Blockchain is both transparent and private at the same time. This may sound confusing, so let's just break it down. On a blockchain, all information is accessible to everyone. Transactions are open, transactions are visible, transactions are verifiable, which means they cannot be misrepresented. Right? This level of visibility creates trust and accountability. Since every action is traceable, nobody can quietly cheat the system. But then there's the catch. Where's the catch now? Privacy is not absolute. Over time, as your data accumulates, blockchain records can be analyzed and then they can be linked back to, oh, that was the holder. You know, when you analyze that, okay, this is the location, this is the height, this is the weight, you can by time analyze and get to the person. That means while transactions may not directly show your name, may hide your name, may fake out your name, patterns can actually reveal who you are, what is your height, what is your weight, what is your locality, and then they can know who you are. So, how do we protect now privacy? We have strong cryptography that ensures sensitive details stay secure every now and then. We have reliable, honest nodes that do not allow leakage out of the system. And in some cases, we go for private blockchain that where access is limited to authorized participants depending on the need of the hour, depending on what the role is. And yeah, so privacy in blockchain is actually just about balance. The system is transparent enough to be trustworthy, and yet using the right tools, using the precautions, it can protect users from exposure. The challenge only is defining how much balance and where are the loopholes, how much balance can you give to the user, right? Yeah, because you have to keep both openness and discretion in place. Coming to the last design principle, we go with flexibility. Nowadays we know, everybody knows, right? Lego is so much in market, so much raised up, alarmed up prices, alarmed up, influence and everything. So if you've ever built with Lego, you know the beauty lies in flexibility. Start small, add pieces, change shapes, and then scale up, all without breaking the structure. Now, blockchain, it too works in a similar way. One of its key strength is actually its innate flexibility. First thing, transactions can be carried out quickly and accurately, which makes it incredibly useful for systems that need to grow and adapt over time. And second, blockchain is designed to stay streamlined and manageable. Even as the network grows, it avoids becoming overly complex. What does this imply? This implies developers and users don't face unnecessary burdens as adoption increases. If I have to keep this in very simple terms, flexibility is going to ensure that blockchains can expand without breaking. We started small, we're building on the top of it, but this small structure, the base, the foundation, isn't going to break up. Whether it's supporting new applications, scaling to more users, adopting to future technologies, it can evolve while staying efficient, evolve while this foundation remains strong. So this flexibility makes blockchain not just a rigid ledger, but a living system, one that can grow, one that can adapt and stay relevant as technology and users' needs change. I hope you were able to understand all the concepts. If not, please make use of the comment section. Please make use of the G form attached. And if you were able to extract 10, 20%, howsoever percent out of the video, if you thought video was helpful for you anywhere along, just go, please like, subscribe. Thank you so much. Stay tuned. Bye bye.